Binomial Theorem, Chapter 8. Bi means to, Binomial means, here we mean mathematical expression involving two terms. And a theorem based on this binomial expression, binomial theorem, we discuss here. The statement and the proof discuss and related results also we discuss. The most simple form of a binomial expression is A plus B. Two terms, A plus B. It can be A minus B also, A minus B also. And the binomial theorem says the expansion of A plus B all raised to n, where n can be an integer, a fraction, and so on. We consider only this expansion for this n a positive integer. If n is a positive integer, then the expansion of this A plus B all raised to n. Given this as a theorem, and we prove this theorem using mathematical induction. We prove this result is true for n equal to 1. Then assume the result is true for n equal to k. Given the expansion will be given. And then we prove the result is true for the next higher value k plus 1, and thereby establishing the proof, the theorem, the result. Now we can consider the first 2, 3 or 4 expansions, that is when n equal to 0, when n equal to 1, when n equal to 2, 3, we can consider here. So when n equal to 0, A plus B all raised to 0, which is equal to 1. Which is equal to 1. When n equal to 1, A plus B all raised to 1, which is equal to A plus B. A plus B. A plus B. When n equal to 2, A plus B all squared, which is equal to A squared plus 2AB plus B squared. So which is the expansion of A plus B all squared. And you know this A plus B whole cube also. This A plus B whole cube is equal to A cube plus 3A squared B plus 3AB squared plus B cube. You know this also, you have seen earlier in the previous classes. A plus B whole cube. Similarly, we can find this A plus B all raised to 4, A plus B all raised to 5, etc. And you have seen up to this A plus B whole cube, and in the case of this A plus B all raised to 4, what we do is, A plus B all raised to 4 can be considered as A plus B whole cube into A plus B. Then write A plus B whole cube with this, multiply this with the A plus B term by term and rearrange the terms, etc. We will be getting the expanded form in a specific form. And now we can see certain specialities in this expansion. Here n equal to 0. There are n plus 1 terms in the expansion. First property. N equal to 0, so n plus 1 terms. N equal to 1, n plus 1 terms, 2 terms. N equal to 2, 2 plus 1, 3 terms. N equal to 3, 3 plus 1, 4 terms. If n is 4, then there will be 5 terms. If n is 5, then there will be 6 terms. And if for this A plus B all raised to n, there will be n plus 1 terms in the expansion. Okay. Again, in this expansion we see that, and consider these two. These two are very simple forms, and therefore we do not consider this for discussion. We can consider these two. The expanded form is in such a way that this power of the first term is this n itself, and there is no term, the second term in this, and then advancing we see that the power of this first A reduces by 1 and that of B increases by 1. So A squared to A here, then here there is no or B raised to 0. We can say there is B raised to 0. Then B increased to 1. Then again A reduced 1 again, B increased, so B squared. Here also same situation. A cube, then A squared B, A1 reduced, B1 increased, A B squared again, power of A increased, decreased, then B increased, power of B increased, then B cube. That means the total, the sum of exponents of these A and B is equal to n. A cube 3, A squared B, power of A is A squared 2, 2 plus power of B 1, 2 plus 1 3. Here also 1 plus 2 3, here 3. So the total sum of the exponents of these A and B same n. And again consider the coefficients, consider this last one. Coefficient of this is 1, this is 3, this again 3, this is 1. And this one can be written as 3C0. See combination, 3C0, 3C0 is 1. This is 3C1, 3C1, 3. This is 3C2, 3C2, again 3, and this is 3C4, 3C3, 3C3, 3C3 is 1. Here 2C1, 2C0, 2C1, 2C2, coefficients. And in this way we can write this A plus B all raised to 4 very easily using these properties we have discussed. We can write this. So what will be the form A plus B all raised to 4 will be 4C0, which is 1. A raised to 4 plus 4C1, this 3C0, 3C1, 3C2, 3C3 in this way increasing. 4C1, then power of A reduced to 1, power of B increased by 1. So 4C1, A cube B plus 4C2, A squared B squared plus 4C3, A B cube plus 4C4 A B raised to 4. A raised to 0, B raised to 4. That is 4C4 B raised to 4. So this will be the expansion in a similar fashion using these results. Okay? And the expansion of this will be in a similar form. nC0 A raised to n plus nC1 A raised to n minus 1b plus nC2 A raised to n minus 2b squared plus etc. plus last term nCn B raised to n. So this will be the expansion of A plus B all raised to n. And this is binomial theorem. The expansion of A plus B all raised to n equal to this, and this is binomial theorem. We can prove this binomial theorem by mathematical induction. We assume this is true for n equal to 1, showing this. Then assume this is true for n equal to k, then prove it is true for the next higher value n equal to k plus 1 also. Thereby establishing the theorem. The theorem is true, the result is true. Okay, so the theorem and the details can be in the next video. Okay.